Hello everyone, my name is Xinhui Tan. I want to present our topic for today's that is collaborative bug finding for Android apps. This is a joint work with my undergraduate students at that time, that is Zhichang Li. Both of us are from Southern University of Science and Technology in Shenzhen, China. I want to start these presentations with a motivations. There is a study that aims to answer the questions, how do developers test Android apps? One developer say that they have not actually found any easy to use testing solutions for Androids. While another developer admits that a lot of what they are doing is related to how the app is looking and then also feeling. Therefore, a lot of testing is done manually. So these studies give us two observations. That is, developers mostly rely on manual testings and also unit testings, while developers actually prefer automatically generated test cases in natural language. Meanwhile, we realize that many bug reports actually exist in open source repository like GitHub's. In these examples, two bug reports that you see here, the app developers who develop Pocket Hubs and also Fort Hubs are able to find similar bugs across these two apps. While Pocket Hub and Fort Hub, they are both YouTube clients, it's quite expected that we can find these similar bugs across these two apps. But what is unique is that we even find the similarities between these two apps of completely different category. One is camera color picker, that is the one you see in the left hand side, and then Guno Cache, the one you see in the right hand side. For example, in the second bug report title, we see that because both apps are relying on Gradle for compilations, they need to make Gradle the build file being executable for future easy compilations. So this tells us that there exists one-to-one correspondence almost in the bug report titles in the apps of different category. So now you may be wondering, what is so special about bug reports? Bug reports give us what is called test scenario. A test scenario may include things like steps to reproduce this behavior, and then test data. Test data, for example, for an image processing apps could be an image that is quite difficult to generate automatically. And then also the expected behavior. This could help us to solve the test oracle problem. Now let's introduce our approach, collaborative bug finding. It's actually inspired by the concepts of pair programming. If you are familiar with pair programming, you know that there are two different roles. One is the navigator and then one is the driver. So true pair programming is known to give several benefits, including because the navigator is constantly looking at the screens, so it could help the driver to find bugs in the code that is being written. So we want to bring these concepts into bug finding by emulating the role of pair programmer using other similar applications. That is, we design three different settings to model different interactions, but in all these settings, we have other Android apps as the navigators, and then our own apps under test will be the driver who will drive through the bug finding process. We first actually try this idea of collaborative bug finding in classroom settings, where I was teaching a software testing class with 29 students in SUSTech, and then we are using GitHub Classrooms for teaching students, and then we try on two different settings. In one settings, basically students share the bugs that they find through GitHub, particularly in GitHub discussions. And in the second setting, students manually search for relevant GitHub issues. Let's look at one example bug that students found. In these examples of issues, what is the main problem here is that for an app that is a note making apps, the counter when you after adding a new node to this new category, the counter has not been updated immediately. So after reading this bug report, and this student actually shared the bug reports in GitHub discussions, another student finds similar bugs, but in another apps. That is, he find that after he tried to import the new subscriptions in the files, even though we see here that it's shown that things are being imported, but the imported content have not been shown immediately. So these problems is the fact that the view are not being immediately updated. We only update the view after restarting the apps. This turns out to be a prevalent problem that affect quite a few apps. Well, students find that the settings that we try in classrooms is actually quite time consuming to search for similar bugs. We propose a new approach called Bugine that trying to recommend similar apps. We use the similarities by looking at whether the app that we have in our database and the app under test share some similar GUI components. And then when this app in the database have the bug report that mention the shared GUI components, we will try to recommend these apps to my apps under test. The details of Bugine could be found in our paper. Now let's look at the effectiveness of Bugine. It turns out that the Bugine can actually find quite a few number of new bugs. It finds 24 bugs, while in the first two settings, 29 students find 17 bugs in 20 apps. So we conclude that Bugine can actually discover more bugs even though we just evaluate it in 5 apps. In summary, I have proposed and described our new approach of collaborative bug finding. We are reusing bug reports from different apps by exploiting the redundancy of bug reports in GitHub, and we use the similarities between apps. What is more important is that we propose a new way of testing Android apps. Instead of test input generations, we reformulate the test generation problems as a bug report recommendation problems, and our two Bugines can recommend relevant bug reports automatically. So in this case, we achieve the effect that developers could read these bug reports because it's written in natural language, then they don't need to learn a new testing framework or API. And our approach is effective because can find 51 new bugs, 5 of them have been confirmed, and 7 of them have been fixed.